So welcome to our first lesson of the evening. We're going to work with comparing and ordering rational numbers. This is going to be our first lesson, and there will probably be several lessons that go along with this assignment here. One of the things I want to bring to attention on comparing and ordering rational numbers is I want to kind of define what rational means. Rational basically just means numbers that can be represented as fractions. So any number that can be represented as a fraction is called a rational number. Again, fractions, remember, means we have to have a numerator and a denominator to represent a fraction. Let's look at a few examples that we may not be familiar with. Let's represent 5 as a fraction. So to represent 5 as a fraction, the easiest way to do that is just put this as 5 over a 1. And now 5 has become a fraction. And notice that it still represents 5. Also remember, a fraction is a division problem. 5 divided by 1 is still going to give me 5. Also, if I wanted to, I can use like 10 over 2. Because 10 divided by 2 is still going to give me 5. Notice that 2 does go into 10 5 times, so that would represent 5, and that is a fraction. You also could go something like maybe like negative 20 divided by negative 4. That would be 5 as a fraction. So as long as the numerator and denominator simplify back down to 5, these would all be correct. A more common way of changing 5 to a fraction is really just putting 5 over 1. So in most of our math, we'll just probably just put 5 over 1. But there are sometimes needs for these as well if we choose to do so. Where this happens a lot of times is we talk about slope of a line that may occur in those areas. Let's see, represent 8/10 as a fraction. Remember, place value, this is the ones place, because there's the decimal. There's the ones place. This is the tenths place. So we would read that as 8/10. And notice that if you can read that decimal, you can actually just change that to a fraction just like that. So 8 over 10 would represent 8/10. Now, one thing we also could do here is put this in Lewis terms. And since I can divide the numerator and denominator both by 2, that's reducible. Also note that really what you're doing is you're dividing by 1, because 2 over 2 really represents 1. And if you divide by 1, it really doesn't change the value of the problem. It's still what we call an equivalent fraction. So if I go ahead and divide this out, we end up with 4 over 5. So 8/10 is equivalent to 4/5. So we call these equivalent fractions. So equivalent is another fancy word for equal. So equivalent fractions happens a lot of times when you reduce or rename the fraction. This is a little bit different here. Represent 2 and 75/100ths as a fraction. So notice how I come across here and say 2 and 75/100ths. So a lot of times the word that goes in place of the decimal is the word and. If you ever write a check, when you write it out in words, you have that and word go along with your check. So if I want to change this 2 and 75/100ths, what I could do is write this as 2 and 75/100ths, like so. So when you see a mixed number, these are also kind of joined by, when you have a number next to a fraction like this is also considered 2 and 75/100ths. Now notice how I can actually reduce this down. So I could say this is 2 and 3/4, because I can divide the numerator and denominator both by 25. So 25 does go into 75 3 times, and 25 does go into 100 4 times. So I can change that to 2 and 3/4. So 2 and 3/4 would represent 11/4 altogether. And now I've completed the process of changing to a fraction. So remember that little shortcut. If you multiply 4 times 2 plus that 3, that will tell you how many fourths are present. So 2 and 3/4 would change into then 11/4. We'll talk a little bit more about that as we move into our lessons. So stay tuned.